All right, welcome to the first pure programming lesson using p5.js, and we'll also show you the processing version at the end. What we want to do with this very first lesson is give you a bit of a taste of the way this language works, how it's set up. Do something really simple, but get something interesting on the screen, and use that as a starting point for all our other programming after that. So just so you know, I've created an account with the editor.p5.js. If you just type p5.js, it'll take you to p5.js.org, and then one of the links will be into the editor and it takes you into this screen. What I recommend you do if you're going to follow this series along is to create an account, and that way it saves all of your programs if you tell it to at the end of each single program. So let's talk about the way that this software works. Or this language works. So the processing language has a setup function and a draw function. Now, functions are a chunk of code that you can reuse over and over again. It's a common term in programming. You may hear other similar terms, subroutines, methods, functions. There's lots of other different terms for that. And there's two built-in functions that are used in p5.js. One's called setup and one's called draw. And what you will find when we use this in a few minutes is that the draw function is what's called a looping function. So what that means is anything that happens inside draw is going to loop over and over and over and over again. So what we're going to do here today is we're going to recreate the exact same first lesson that I would do with my students on day 1 or day 2 of my entire course. And that is to just get a little bit of text moving on the screen, get them thinking about how this language starts to work, and then we use that as a leaping point, obviously, to inspire them in the future. So here's how this works. We've got a function called setup, and that's the stuff that gets run once to set up your screen, and it uses a function called create canvas 400. Now, if you hit the play button here on the right side of the screen, it's going to create a gray box that is 400 by 400 wide. So if you wanted to make it a little bit wider, you can say, for example, if I go 600 by 400, it will do that. Now you can adjust the sizes of your screens a little bit if you need to. But generally speaking, when you're first starting, you just kind of want to go with something very simple, but maybe change the dimensions a little bit as you go, just so that students can differentiate. The first number is like your width, or will also be very commonly considered your x-coordinate moving across. And the 400 is your height or your y-coordinate, although you will find a little bit different than math. In this case, the 0 point starts in the left corner, which means as you go down, your y-coordinate gets larger. That'll become clearer as we progress through. Now, then there's this function called draw, which has an inside line of code called background. So let me talk about the structure of this language. This structure is a common structure in programming languages, but not entirely. So this language uses what I like to call with my students, because it's easier for them to see, especially visually if they're trying to follow me along, say on a projector screen. I like to call these brackets, so the standard brackets open and close, and I like to call these curly braces. Now, that's definitely not the case. I believe English teachers will tell me those are actually called parentheses, but I find that if you use the term curly brackets, it's easy for students to realize what it is you're talking about. And so this common setup of having something with a set of regular brackets followed by a set of curly braces is very common. And what happens is anytime you have an open curly brace and a closed curly brace, this is a block of code that all works together. So everything inside a set of curly braces is a chunk that is designed to work together or to be run at one time in many cases. So inside this, we only have one line. Then you'll notice here's that same structure again repeated. Bracket, curly brace, curly brace. You'll notice that if I click next to one of those curly braces, it highlights its corresponding curly brace. That's an important, useful troubleshooting tip so that you can often find mistakes. It's very common for students to forget to close off curly braces or to have too many of them once we get into the things that are more complicated. So that's a little quick tip. You'll also notice that this language either lines start or end with a closing curly brace, or you're going to see they tend to end in a semicolon. So the semicolon creates what's called a statement, a single line of code that's going to get run. The curly braces generate a block of code that's going to have several statements on the inside. And in many languages, again, not all of them, you'll find that semicolons are often used as the ending point of a statement. Python is a language that you probably have heard of or may have heard of that doesn't use either of those conventions. It doesn't use curly braces. It doesn't use semicolons. What instead it uses is white spaces and enters to indicate new statements and things like that. And that is just a different way to do things. This is, I would say, more common to use the semicolon and these bracketing formats, but not necessarily the only thing. Okay, let's do something interesting. So first of all, background. So background is, as you can imagine, the background for this canvas that was 600 by 400 wide. Now, the programming language that we use works up to the number 255. You're going to see that we're going to regularly go between 0 and 255. A little bit later, we're going to talk about sort of binary numbers and why the number 255 is important. For those of you who maybe do know a little bit of binary and computer math, a 255 is the highest number you can store with 8 bits, or 8 ones and zeros. We'll talk about that a little bit later on. So 255 becomes a common number that is used a lot in programming. And so if I make this number 255 and run it again, what you're going to see is that this goes fully white. I don't know if you picked it up on my computer, but hopefully you run it. If I go closer to 0, if I go all the way to 0, you're going to see that that is black. Okay, so a single number in background, 0 to 255, will take you from black to white and all the grayscales in between. So again, if I say make this 50, it'll be close to black, but a little bit lighter. I don't know if you picked up on the screen. Now, the other color convention in processing in P5.js is what's called the RGB, red, green, blue. And red, green, blue means you can set all 3 of those colors up to the number 255. And why red, green, blue? That's one of the standard color schemes in computing, and it actually matches up apparently with the color receptors in your eyes, and that is why red, green, blue is chosen as a common color scheme in computing. So what I mean by that is, here's a red. We'll say 50 I've got as red. Maybe I'll do 100, 100. So now I've got 3 things. So notice the way it is red, 50, 100, 100 inside the brackets, semicolon. And now I've created some kind of color that's a little bit hard to distinguish what that is. If I want to make this a lot closer to, say, a blue, I would make that number all the way up to 255. That's maximum. If I made these 0, you'd have full blue. If I made it 255, 0, 255, that would make it a purpley. In this case, it looks a little pink on my screen. Now, what I would recommend you do is just take a moment, pause this video, play around with the color schemes, see if you can figure out what the color code is for yellow, and then run it again. So I will change that to yellow here in a second. Let you pause the video first, if you're interested, and there's our yellow. Okay, now, we said we're going to do something more interesting right away on our screen. So what we're going to do is start working with some text. We're going to just demonstrate how you make text on the screen, and then we're going to get that text moving a little bit just so you can sort of see some of the power of the language pretty quickly. Okay, so what I'm going to do is I'm going to create a text size up here in the setup function, so that any text I do will be that size. So you can always change sizes and colors, etc. on the fly. If you know you want to go with something and keep it for the entire program, you can put it up in the setup, and then it'll propagate through until you tell it to change. All right, let's get this thing rolling. So what I'm going to do is I'm going to draw some text on the screen, then I'm going to increase its size and its colors, and I said get it moving. So here's how you write text in processing P5.js. The line of code is text, and then it has its own brackets and its semicolon. I do suggest when you're first working with kids right away, you get them to put the brackets and the semicolon in right away, especially if they're trying to type along with you, because they'll make mistakes. Then what you need to do is tell it what words to write. And in processing, we always indicate words in something called a string. A string is like a string of characters, or a bunch of characters strung together. And in processing, as is the case in a lot of languages, they use the traditional double quotes to indicate what's going to be in here. So what I like to do with my students is just have say something about an event coming up in the next few days. Kind of make it like it's an announcement. They're going to make this like an advertising banner or something like that. So what I'm going to say is week of welcome. Maybe there's going to be a party or something. So I'm just going to say fun starts Monday. So there's my text. So you put that in quotation marks. Then what you need to do is you need to tell it, so there's a comma, where it goes on your screen. And where does it start on your screen, I guess is a good way to put it. And so I'm just going to show you 50, 50. And 50, 50, we'll put it at the 50 point in both directions. So let me kind of let that run and explain what's happening here. So here is 50 to the left, x coordinate, 50 down to the right, y coordinate. Again, y gets bigger as you go down. So just to demonstrate, if I wanted to center this somewhere in the screen, my left, well, my screen is 600 wide. I'm not sure exactly how wide my text is. So if I want to, maybe I want my text to be like somewhere over here. So if that's 50, maybe I want to go, maybe say 150. So if I do that, it's getting close. It's not perfect. So maybe, I don't know, we'll just say 175 to just play around with that x coordinate a little bit. I'm not going to be too worried about it for this video. That's pretty darn close. And then the height, or the y coordinate, is the second number, and we're at 400. So I'll put it at 200. Now I don't know if you'll be able to tell from this writing. If I put it at 200, it's actually just slightly down from center, because in fact that starting point is the upper left corner of my W. Now it's a little bit harder to see that unless we make a bigger font. So let's go up here and do this in setup, or we can do it right before our text. But I like to do it in setup at first if I'm only going to do something quick. And we're going to say text, and it's a capital S size. So you'll notice, if you look at the word create canvas and now text size, you'll notice that the first letter starts with a lowercase, but then whenever I get into a second word, it goes to an uppercase. This is a common programming convention in a lot of languages called camel case, meaning that when you have new words, you have a hump in the cases. The capitalization does matter. It is very crucial to keep the proper punctuation, or it simply won't work. And so text size, I'm just going to say maybe make this a 20, and I'll rerun it, and there we go. And so now you can see it starts to go. And of course, if I want to make this centered again, then I'd have to readjust this 175 to make a little bit left, because now my text is bigger. But that's not what I want to do, because I said I want to make this text get moving. I'll do that next. I want to deal with colors first. So if I want to make this text a new color, I have to go above that text. And that'll become more obvious once we start drawing multiple things in the next video. So the first thing we're going to do is we're going to say I want to make this a different color. And I'm going to use the two terms. It's called a fill and a stroke. Fill is the inner part of the text, the inner part of any shape. So if we draw like a rectangle, the fill will be the insides, and what's called the stroke will be the outside line of it. Now text also has a fill and a stroke in p5.js, and so we can set both those if we want. So let's say we want this to be red, so I would say 255, comma 0, comma 0. And close my brackets and run that. Whoops. And you'll see this is now red. I think that'll show up for you. There is what's called a stroke for text as well. So if I want to make that black, I could go to that one number system to make it black. And you could probably see that that's got a little black outline. If I made this text quite a bit bigger, let's say I go 40 and play it again. Now you can really see that there's, maybe you can see that the black is text. There's also something called stroke weight, which I'm not going to get into in this video, which would make those lines a little bit thicker for more interesting things. So fill, stroke. Fill is the inside color, stroke is the outside color. Text is drawn using words and quotes and a location. Text size, can get this changing. If you want more than one text size, what you'd probably usually put a text size right above this. Draw, add another text size line with right before you draw more text. So we'll show you that a little later on. All right. So last thing I want to do is talk about getting things going. Now I'm going to use a variable for this, and we're going to talk more about variables in about 2 videos from now. So I'm going to do this really, really quickly. So don't panic if you don't understand this right away. But a variable is basically a slot in memory that we're going to reserve to use in our program. We're going to put a number in that slot. So I'm going to go up to the top. So before function setup, I'm going to use the word var for variable, and I'm going to give this a name. And I'm just going to call this, because I'm going to get this to kind of scroll to the left, I'm going to call this scroll X, and I'm going to use a capital X just because, again, to keep that camel case going. So scroll X is going to set up a variable. If I set this variable up outside of these two functions, then I'm going to be allowed to use it in any two functions. Again, we'll cover that a little bit more in a little bit of detail later on. Now I'm going to give scroll X an initial value. So this is creating a variable. Inside that I'm going to say equals. I'm going to go back to my original 175 just as a starting point. Because what I'm going to do down here is I'm going to say, let's not do this at 175 anymore. Let's do this at scroll X. Okay, so again, making sure you get the same capitalization there. So if I run it, there shouldn't be any change, because what we've done is we've created a variable called scroll X. We put the number 175 into scroll X, and then we just said, hey, instead of what we call hard-coded number, we're going to have a variable in there. So now what we want to do is get this variable to change. That's the whole point of a variable. We want it to vary. So we're going to get it to change. All right, to get this moving, we need to simply tell this variable to change. So remember that I said, maybe it was in the other video, that the draw function is a looping function. So what that means is that every time the draw function is run, whatever happens is going to run over and over and over again. So what I'm going to do is I'm going to go at the end of this, and I'm going to say, let's change scroll X. So scroll X equals what used to be in scroll X. So we're going to say scroll X plus 1. Now, what this is going to do is it's going to add 1 to scroll X. So originally it was drawing at 175. Now it's going to draw at 176, and it's going to draw at 177, 178. So it's going to do this. So that looks okay. That's not too bad. It's a little bit slow, so we can change that number. But it'd probably be better if we got it to go this way. So as you can imagine, if we want it to go that way, we need to subtract minus. Maybe let's get it to go a little bit faster. Maybe let's go -2. So now scroll X is going to get smaller as it goes across the screen. And the last thing we want to do with this this first lesson is to say, once it's off the screen, well, wouldn't it be nice if it worked more like one of the old school banners and go to the right side and keep going across the screen? So what we want to do is just, okay, when you're going left, that's fine, but let's get it to jump back to this. And so now we're going to use what's called an if statement. And an if statement is one of the key structures in all of programming that says, if something is true, do this. And here's how that looks. And we're going to use this particular structure again and again and again. I'm just going to stop that from running, because otherwise that program is still tracking where my text is, and right now it's somewhere halfway into my living room. So what we do is we say if, square brackets, curly brace, close curly brace. So again, I do recommend you keep to that structure and open and close those right away at the beginning. Inside these brackets is the thing that you want to test to be true. So the way it works is you say, okay, if that variable, scroll X, and again, we'll take a lot more time with this a little bit later on. If scroll X is equal to a certain number, we're going to get it to jump to the other side. Or actually, what I recommend you do is do a less than a certain number, because remember, we're minusing 2. So if we ever happen to say, if we miss the exact number, it's going to keep on going. So let's say if scroll X is less than 0, if scroll X is less than 0, then what we're going to do is we're going to set scroll X, I'm just going to even up those curly braces, to be back to the other side of the screen. So the other side of the screen is 600 wide. Maybe we'll go a little bit past that just to make it a little bit off screen, maybe 620. So let's see what that looks like. So it's subtracting 2, and then it says, oh, as soon as scroll X is less than 0, it sets scroll X to be 620, so now it starts back over here, which looks pretty good, except for you're probably thinking to yourself, well, this is not bad, but 0 isn't necessarily the best way to go. So what do you think would be the best number? And this is where you get your students to go in and do a little bit of experimenting, and of course that's going to change depending on what text size they've used. So you may even ask them to all use a different text size. Maybe say, pick what month of the year you're born in and multiply it by something, so they all have slightly different text sizes, and then they all have to go and figure out the exact number so it jumps screen as soon as it leaves. So I'm guessing on this case, my text is almost, actually in fact right now it's bigger than my 600, which probably means to get all the way off the screen I would go less than something like -600, and that might not even be enough as it is. So let's see how this goes, and if that's the case, we're going to end this first program here. Not quite, so I actually have to probably go about 650 or 700. Obviously, you can play around with this. So this is the lesson we use in my, part of the lesson I use in my very first unit. If you go and look at lesson plan, the beginning of the programming unit 1, you'll see this lesson plan. The way it essentially looks in the standard processing is this. So different than in p5.js where there is a create canvas. This also has a setup function and a draw function. It uses size is a different code, whereas the other one is create canvas. You'll notice that the background, the text size, all the other code so far is the same. Oh, except for the variable. So in processing, and again, we're going to talk about this a little later on in a video dedicated to variables. In processing, you have to indicate a particular type of variable, in this case, an integer variable. Whereas in p5.js, you don't need to indicate the type of variable. You just can use the word var, or there are a couple other options as well to use. So this is our lesson 1. What I would often do is kind of do right towards the end of the class, just to get kids interested and excited. You give a couple minutes of challenge, say, hey, play around with the colors, play around with the sizes, play around with that speed, see if you can get it to go up and down as opposed to right and left. Get them to experiment a little bit, and that'll tee them up for the next lesson, which we're going to talk about shapes. And that's where we really do the lesson that kind of really hooks students as well, is working with shapes and colors. So we'll see you there.